Hi, hello, year 10. So this is our 8th video for our algebra. Okay, so this lesson is about the factorization of difference of squares. Okay, so let's start. Okay, so we've learned this. So this is what we call difference of square, or DOP. Okay, so from the left hand side to right hand side, we've been doing that expanding before, and going back is what we call factorizing. Okay, let's see how, if we still remember how to do the expanding, then we are going to reverse the process, then you know what happens. Okay, so if we are going to expand, that's the left hand side to right hand side. Okay, we remember the rule for DOP, the difference of square. Okay, so difference of perfect square, right? So if you got this, if you use the so-called FOIL rule, you will get a squared minus b squared, just two terms. So it's very special. Okay, so if we got this one times this one, okay, so you see that's a is 2x, b is 7, so you got 2x minus 7 times 2x plus 7, so the difference times the sum. Okay, so the second step, we will have bracket 2 squared. Remember that bracket is really important. Okay, and then when you got square, you need to square everything inside the bracket. So you have 4x squared minus 49. So that's what we call expanding. Okay, so what do we mean by factorization? For factorization, we just need to reverse the process. Okay, so the question will give you 4x squared minus 49, and all you need to do is to write things backward towards two brackets, 2x minus 7 times 2x plus 7. Okay, so that's what we are going to do. You reverse what you have done before. Okay. Okay, so the first situation is when both terms can be made perfect square. Okay, both terms can be made perfect square. What do you mean by perfect square? For example, 25x squared. 25 is a perfect square because 5 squared equal to 25. Okay, 5 squared equal to 25. 9 is a perfect square. It's a square number because 3 squared equal 9. Okay, so if you got things like this, step 1, write the both terms into perfect squares if they have not yet been. Okay, so for example, 25x squared, so you need to rewrite them into bracket 5x squared. Okay, remember that bracket is necessary. Without that bracket, it's different string. Okay, for 9y squared, 9 is 3 squared, so you can rewrite that as bracket 3y squared. So now you will have a square minus square. So we know that when square minus square, you got the product between the difference and the sum. So that's why that's 5x bracket square minus bracket 3y square. You got 5x minus 3y times 5x plus 3y. Okay, so that basically what's the idea about how could you factorize the difference of two squares. Okay, so the idea is to write the first term and second term both into squares, and then you use the simple facts that a squared minus b squared equals the product between the difference and the sum. Okay, so how about this one? Let's track. Okay, is 4 a square number? Yes, 4 equals 2 square. Is 1 a square number? Yes, 1 square equal to 1. So 1 is a very special number because it's square just itself. Alright, so let's see how could we do that to factorize the expression. Okay, so let's copy the question like this. Then the first part is 2x bracket square minus 1 square. Okay, so remember that's bracket square, bracket 2x square minus 1 square. Okay, then you got 2x minus 1, 2x plus 1. Okay. Okay, so for the second question, Okay, I might give you some time to think about this. All right. Okay. So think. First question: is 81 a square number? If it is, what's the what square number? So the square of what number equals 81? The same question for 49. Is 49 a square number? If it is, okay, the square of which number will give you 49? Okay. Try to think about that. Okay. And if you get that, you should remember that 81 is 9 square. Okay, so the first term pretty much can be rewrite into bracket 9a bracket square, because 9 square actually equal to 81. And for 49, 7 square, so 7 bracket b. Alright, so then you have square minus square, so you got 9a minus 7b, 9a plus 7b. That will be it. Okay. All good? Okay, so let's can I get you to try some of the questions here? Okay, so pause the video now and you try to do the first 3 questions and we check the answer, alright? Okay, please check the answer. Are they correct? Okay, so that's basically what happens. Alright, so always turn the both terms into squares, and then you could use the simple rule. Okay, alright, okay, so next one. Okay, so sometimes the square is not for a single term, but for a binomial. Okay, then you could still use the rule. For example, if you see this one, okay, let's focus on this one. So you got x plus 2 bracket square minus 4. Okay, when you just look at this, you might think, how about I expand that x plus 2 square? But it's not the case, because if you are going to factorize them, we don't try to expand them, because expansion and factorization, they are two opposite operations, right? So you might think, okay, if I treat that x plus 2 as one thing, as one term, okay, so I just treat that bracket x plus 2 as one single thing, and that's 4. Okay, 4 is a square number, so you see that's x plus 2 square minus 2 square. So I just imagine this as a square, sorry. I just imagine this is a square minus b square. Then what should we get? We should get a minus b and a plus b, right? So a is now not just a single term, but a bracket of 2 terms, which is a binomial. So a is x plus 2 minus 2. Okay, b is 2. Okay, and so when you apply that a square minus b square equals a minus b times a plus b, then simply just put all the things into the place. Okay, so you will get x plus 2, which is a, minus 2, which is b, and x plus 2, which is a, plus 2, which is b. Okay, of course you can simplify them. For the first part, x plus 2 minus 2, that means x plus 2 plus another 2, that means 4. Okay, so the final answer will be x times bracket x plus 4. Okay, so you see that how it works. Okay, so even there's a bracket of square, you could just again use that rule. Okay, just treat it like a square minus b square. Okay, how about if there are 2 brackets? If there are 2 brackets like this one, there are 2 brackets. Okay, then what happens? Again, you just think of this one as a, this one's b. Okay, so that's a square minus b square. Okay, so for a square minus b square, again, it should be a minus b and a plus b. Okay, but be careful here, because that b is not just a single term, it's 2 terms in a bracket, so you need to keep that bracket. Okay, I need to emphasize that a little bit. You need to keep that bracket. Okay, when you remove the bracket, then you need to change the sign inside the bracket for the term following. That's minus sign, so it becomes x plus 2 minus y plus 1. Okay, so that in that case, the first part will get you x minus y plus 3. For the second part, is x plus 2 plus y minus 1, and you remove the bracket. This time you don't change sign because this is plus in front of bracket, and you will get the answer, right? So even there are two brackets, still imagine that as a squared minus b squared. That's all algebra about. So algebra is about generalization. Okay, you need to think things in an abstract way. Okay, right? So when you got a square with two terms, sometimes you can view this as just one single square. Okay. Okay, let's have more work. Okay, so the first one. So when you are going to factorize them, okay, so remember when the question is about factorize, you are not going to expand the term. Okay, that's not what we are going to do. If you are going to factorize them, try to make them into brackets. Okay, not to expand them out of the brackets. Okay, if you try to expand them, it becomes expansion. All right, so how could we do this one? Okay, let's say if we got 25, actually 25 is square number, so you have this one. All right, so that means you can treat that's 5 as A, that's x plus 3 as B, so you got this one. Of course, we need another bracket here. Another bracket, 5 plus x plus 3. If you could see it, that's really good. And of course, you have to simplify them. To simplify first, you need to remove the bracket, the inner bracket. Okay, so when that's minus sign outside that bracket, you need to change the sign in it, and you got the second one, you got this one, right? So you got 2 minus x, 8 plus x. That will be it. Okay, so that's the first part. Okay, for the second part, okay, let's see. Okay, do you see 2 square? Yes, there are 2 square, and that's 4. But 4 is a square number, isn't it? Okay, so try to think of the first term as this one. So you add another bracket to square it, because that 4 is 2 square, okay? Okay, then it now becomes a square minus b square, so you could use okay, so that's the first one. The second one. Okay, so basically you've done the factorization. So now you can remove the brackets in that brackets. Now removing brackets is okay because you have done the factorization, right? Okay, so for removing the bracket, you need to multiply that's 2 into the bracket like this. Alright, so for the first part, it was 2x minus 4 minus x, because that's plus, you need to change sign. 2x minus 4, that's plus, you don't need to change the sign. Alright, so please simplify them. You got x minus 6, you got 3x minus 2. That's it. Okay, can you see this? Okay, so let's have an overview for the 2 questions we've just done. Okay, so see, even they have bracket, just use the same method, but you just consider the bracket thing as one single square. That's the idea. Treat them as single squares. Then you can solve it. But of course, you need to be careful about the brackets, and sometimes if you've already got brackets, you possibly need to add extra bracket outside. And also when you remove the bracket after you've done the factorization, you need to change the sign, okay, if that's minus sign outside of the inner bracket. Okay, good. Okay, so I give you some time to finish this. Okay, so pause the video now, take some time, possibly you need to spend the best of 10 minutes to try these three. Okay, so if you're not quite sure about, go back to see the question or use the handout to observe what I have done for this type of questions. You need to see very closely. Don't rush up. Okay, don't rush. Okay. Okay, so have a look. Okay, so for A, just remember that 1 is 1 square, and you need to check the bracket, so the A is the simplest one among the three. Okay, for B, remember that you need to include that 4 as 2 square in the square bracket for the second term. I mean this 4. Okay, I mean the 4 here. Okay, I mean the 4 here. Okay, you need to include that 4 as 2 square over here. Okay, and of course, because there are 2 brackets, you need to create like 2 square brackets for the 2 parts, and then within that 2 square brackets, you can remove this the inner brackets, and you downgrade that square bracket into the normal bracket, and you just simplify the contents, the stuff inside. Alright, for the C, so 16 is 4 square, 5 is 25 5 square, so that make both terms are perfect square. You can do them. Alright, so the same thing happens, but of course you need to simplify the things a little bit. Okay, so that's our difference of square of 2 binomial squares. Okay, so let's see some interesting case. Okay, so sometimes you have to take out a common factor. For example, when you look at, let me zoom in, when you look at this one, okay, 2a squared minus 18b squared. So when you see that, okay, a squared is fine, it's a square, b squared is square, but how about the numbers? When you see that's numbers in front of it, so for example, that's 2. Is that 2 a square number? No, 2 is not a square number. Okay. So that means you can't just write the first term into a perfect square just like that, because that's a 2, and 2 is not square number. And also that's 18 is not a square number as well. Okay, so the problem is if 18 is not a square number and 2 is not a square number, we can't write the things into square minus square. Okay, so it's unlike the previous case when we have a square and you got in front of the number in front of it is also a square number. But if you look at 2 and 18, do they have a common factor? Yes, they have a common factor 2. Okay, so that's why we could take out that common factor of, okay, so that's what we call the common factor. So that's common factor of 2 and 18. After you take it out and you make a bracket, so that's a simple factorization. Okay, so for that simple factorization, you leave behind a squared minus 9b squared. Okay, so now a squared is a perfect square. Alright, and how about 9b squared? 9 is a square number because 9 is 3 square. Okay, so although the previous form, I mean the form here, cannot be written as a square minus another square, but after you take out that common factor, you will have both terms which can be written as square minus square. Okay, because 9 is now 3 square. Okay, so that means for these two terms, you can factorize them using the difference of two squares. Okay, let's see some example. Okay, for this one, is 3 a square number? No, 3 is not a square number. How could we factorize them? Okay, if 3 is not square number, you can't apply that square minus square at the first sight. Okay, to begin with, you need to see how about I take out that 3 as a common factor. Okay, I take out that 3 as common factor. Then what's left behind will be 1 and 25, because 3 times 25 is 75. Okay, so now you got two terms. So what happens here? You got 3. Okay, and you got, let me upgrade that bracket a little bit. And you see, that's 25x squared, because now 25 is square number, but originally 75 is not. So the art of taking out that 3 is very important now. Okay, the action that's for you to take out that 3, so make sure both terms can be perfect squares. Okay, so that means I could just do it like this. Okay, so that's okay. For second one, you see 8a squared, 18b squared is 8 a perfect square? No. Is 18 a perfect square? No. But do they have a common factor? Yes, they got 2 as their common factor. So let's take out 2. Okay, what's left behind? Okay, should be 4a squared minus 9, because 18 divided by 2 is 9, 9b squared. Okay, for the first term, it should be bracket 2a, because 4 is 2 square, right? And 9b squared, 9 is 3 square. Okay, right now you got square minus square again, so that means you can just apply the rule. You got it, right? Okay, not that difficult. Okay, good. Okay, so in both cases, you need to take out a common factor before you can make them into square minus square. Okay, so here's a practice 3. Let me give you some time to work on that. Okay, so now pause the video, try practice 3 and see if you could got the answer. Okay, if you don't understand, okay, don't rush through. Okay, go back to see what I've done for the previous questions. You need to understand how to do. Okay, so let's see. Right, for the first one, you need to take out 2. For the second one, take out 3. For the third one, you need to take out 2 again. Okay, the third one's a bit special because you got a binomial square, but you just do the same thing, right? Okay, that's it. Okay, so let's see the last thing we're going to study. So sometimes it's impossible to write something into a square. Okay, for this one. Okay, let's zoom in. So you see that's a squared minus 3. So a squared is okay, it's a square number, and 3 is not a square number, right? It's not a square number, right? Okay, so the problem is, if 3 is not a square number, can we take out common factor? No, there's no common factor between a squared and 3. So what can we do? Okay, so if we still try to factorize them, in this case, you have to use surf. Okay, what do we mean by surd? Surd means square root sign. Okay, things like square root 2, square root 3, but not square 4, because square 4 is actually 2. Okay, so there are some numbers you can put a square root sign on it called surd form. The others you can just simplify them, right? So the surd form, how could we use surd form? Because we know if we some surd form is quite famous. If you remember, for example, square root 4 is 2 because this is a square number. 9 is 3. Okay, all right. Okay, so what happens is if you have surd form, you square it, then that means 2 squared. You go back to 4. If you got square root 9, you square it. It becomes, so square root 9 is 3. 3 squares is 9. So you go back to 9. So that makes us believe anything inside that square root sign, for example p, if you square it, you just get your p. Okay? So that would be a basic idea. So square root sign something, if you got square root sign and you square, just come back to the things inside the square root sign. Okay? So why is so important? Because that means we can create square out of nothing. For example, if that's 3, can we write 3 into something square? Normally we don't know because 3 is not a square number. If that's 3 is 4, we know that I should put 2 here. If that's 3, what number should we put here? We should put square root 3. So that's the idea. So you could rewrite any numbers into square by using surd form. Okay? Good. Okay, so that's how it is. So when we try to factorize a squared minus 3 using surd form, what you need to do is change that square root 3 into change that 3 into square 3 square. So actually nothing changed, but the way you write the numbers changes. Okay, you add a square sign and you square it, so they just cancel off. But now you got square minus square, so that's very important. You got square minus square, then you got a plus square root 3 times a minus square root 3. Okay, so that's how we create a square even though that's not a square number. Okay. Okay, let's try the first one. Okay, I got 3 minus x squared, can we factorize this? Yes, we can always rewrite that 3 into this one. So that's square root 3 minus x, square root 3 plus x. Okay, so that's the first one. How about the second one? 25x squared. So remember 25 is a square number. Okay, and 7 is another. 7 is not a square number, but we can always create a square number by using square root 7 and then square. Okay. Then you could just do it like this. All right. All good. So how about this one? Okay. So 4. Okay. So the first part is pretty good, because 4 is a square number, but 5 is not. So you create that square out of nothing, and you got this one. Remember, if you got binomial, it's a bit trickier. Okay, sorry, rounding out of boundary. Okay, so you got 2p minus 2. Okay, remember 2 minus 2 minus square root 5, that's nothing you could do. Okay, because they are just different types of number, you can't add them together. Okay, so that would be the answer. You can't further simplify it. All right. Okay, let's see what happens. All right. So the key is when you see the number which are underlined is not a square number, then you could always use square root of that number and square root of that number and square root of that number and square. Okay, then you create the form that enables you to do the factorization of the difference of two squares. Okay. Okay, try to do this free. Okay, you might track the answer, but I really like you to take some time to do it. Okay, you might pause the video again. Okay, and we go back soon to see the answer. Yeah, here you are. Okay, check the answer. Okay, so you need to identify the number that can't be rewrite into what we call square numbers. All right. Okay. So then that's the way you can solve them. All right. Okay. Okay. So that will be the end of this this video. Okay. Before we leave, just have a very quick overview. What happens today? Okay. So today we have learned how to use that a minus b times a plus b equals a squared minus b squares. Okay, we need to do it reversely. We need to do the factorization by using the difference of two square. Okay, so the simplest type will be the both terms are square numbers. So you can just solve it by rewriting them into square minus square. Then you can solve it. Okay, then sometimes you will see that square, the thing under square is not a single term but a binomial within a bracket, or they might be two binomials, square minus square, but you just apply the same idea. Okay, so that's what algebra is good at. You generalize the technique to single term to binomial as well. Okay, and there are some cases that when it's given, you see that the both terms can't be expressed as square numbers. Okay, this time you need to check whether you could take out a common factor. If you got a common factor to take out, then possibly you will see two square numbers for both terms, and then you can just apply the same rule for them, but you need to take out the common factor before you commence that factorization. Okay, and the last thing, which is the most difficult thing, is when the number can't be rewritten or by any means into a square number. Okay, so in this case you can still force them into a square number by using third form. Sorry, you can't force them into square number, but you can force them into a square by using the third form. Okay, so these numbers are those which are not square number, but you can use square root sign to make them looks like a square. Okay, then when you do the factorization, in your final answer you will see square root sign. Okay, so that's what you have learned. Okay, in our notes, I give you some mixed questions for factorizing difference of two squares. There are lots of questions. You might have a try, and I got the answers as well. Okay, so if you finish some of the homework, please send emails to me. Okay, if you like, you could try to do them into OneNote, but OneNote is not that stable, so possibly the better idea would just email to me. Okay, and I could just have a look. Alright, if you have any questions, welcome to ask me through the email, or you might just post your questions in the YouTube. I could see them. Alright, okay, if I got time, I would like to comment or give you a reply. Alright, okay, see you next time. Bye bye.